Hello there. This is my OOP video, and as you can see, or clearly observe, I'm basically the only group member. My other group member left around last week for unspecified reasons, and so here I am, doing basically the only person who's currently recording the video right now. I have much to say, but I digress. Today, I would like to share my application with SDG 13's requirements in mind. This application puts us in the shoes of a hypothetical supermarket that wants to encourage its customers to go green. This is by done by encouraging them to buy greener products and showcasing, educating them on how much carbon dioxide is emitted for each product on buying when buying them, for example. And thus, my showcase will begin relatively. Give me a second. But before I begin, I would like to demonstrate my dataset that I used. This dataset was produced by a user named Vivek, and it's about the environmental impact of food production. This dataset contains 43 entries that are comprised of the 43 most common foods grown across the globe. It also has 23 columns as their respective land, water usage, and carbon footprints. So here's what that looks like in practice. These are the 43 unique values seen here. You can see the variety of products. We have wheat, we have carbohydrates, we have nuts, beans, oils, vegetables and fruits, as well as their related products, coffee and dark chocolate, and then we have our animal products, starting with beef and ending with farmed shrimp. Then we can take note of the land use changes, animal feeds, farms, processing, transport, packaging, retail, carbon emissions, and then the total emissions, which is all of these columns that I previously listed, added up together. Then we have some miscellaneous types of emissions, eutrophication emissions, freshwater withdrawals, greenhouse gas emissions, land use, and so on and so forth, and just a bunch of miscellaneous stats. Altogether, this makes up the 43 by 23 datasets. However, for the sake of this application, I have narrowed my scope down to just simply 40 unique values. If you may look here, you may notice some other values, other vegetables, other pulses, and one more. Where is it again? Other fruit. These I have discarded because they are not very specific and would not serve the purpose of this application very well. For columns, I narrowed it down to simply total emissions, since that's what people really look at when it comes to buying foods. When it comes to global warming, carbon dioxide is the first thing that comes to their head. The works. Hence the scope was changed from a 43 by 23 dataset to a 40 by 3 set. Now you may realize I said 3 despite there only being 2 columns, and that I will explain shortly. And by shortly, I mean now. So as you see here, this is my filtered dataset. Well, not necessarily the dataset, more the TXT file. This contains all the filter results. It has 40 rows, excluding this one, which is just here to describe what each column does. And this is the product number. Yeah, we have, for example, I want products Well, I have maize here. If I wanted to note that in the database, I would input number 2, and then the system would know that, oh, the user is requesting for maize or meal or whatever. As for this column, oh, I actually kind of forgot to explain what this column does. So here, this column is carbon dioxide emissions per kilogram of that product. So for example, referring back to my maize meal example from earlier, 1 kilogram of maize or meal would emit 1.1 kilograms of carbon dioxide. See where this is going? Beet sugar, again, 1.4 kilograms of carbon dioxide emitted for 1 kilogram of beet sugar. Now that I've got a little bit of context over, I will now explain as to why I chose this data set. Because as you may know, the world's population is currently at around 8.2 billion as of this year. It has been projected to increase to around 10 billion-ish around by 2100, according to one United Nations report. And given that our world produces about 4.8 billion tons of food annually, we can only expect this number to increase as the world's population grows. However, accounting for this, we must consider that food production accounts for a quarter of the world's global greenhouse gas emissions. And therefore, we can also assume that this percentage will also increase. If I may return to the dataset earlier, I would like for you to observe that some products have greater carbon emissions compared to others. Sorry about that. As you may see here, all of these animal-based products have much higher carbon dioxide emissions than compared to plant-based. And so, what my hypothetical application will do is try to encourage its users to go for greener foodstuffs by educating them and showcasing that, oh, hey, you should try buying some plant-based products instead of just going for solely beef, for example. I mean, just look at it. 1 kilogram of beef from beef herd is almost about 60 kilograms of carbon dioxide produced. That's kind of crazy. But as I was saying, I would now like to showcase my flowcharts. This is the rough structure of how this program will start. We have a start, and then welcome entity. This functions or calculations or whatever. Inside this welcome, I will initialize an empty array list of products, which is read from the txt file I demonstrated earlier, as well as an empty array list of a cart. Then the user enters a choice from 1, 2, 3, and 4. Anything else is simply renders an error. So we go for a switch statement. If the user inputs 1, they will be showcased the products list, which simply prints out this array list with a for loop. For 2, the user will be directed to buy products, where the user can input the product ID, and then using binary search, the system will find said product and then add before asking the user for the quantity of how many kilograms of whatever product you want here. Then the product's name and the quantity will be added back into the carts array list from that was defined here. And then the cycle loops until the product ID is done, until the user input's done. I'll explain how the product ID can accept string inputs later. Then for method number 3, It's basically just displaying the cart here from earlier. But it's not necessarily defined in the program. I'll get to that in a bit. Then for 4, we exit the shop. The final carbon emissions are calculated. And then if the final emissions are under a certain amount, for this case, it will be under 50, the system displays a congratulatory message. Else it will try advising the user to shop greener next time, and thus the application ends. Let's now look at class relations. Because you see, I have 3 classes here. And this is my class model. We have products. We have each each object correlates to a column from this txt file. ID, the product name, and the carbon dioxide emissions. Then for the cart item, this will be you could call it, I suppose you could call it an associative entity since it relates to both. We have this products class here. Then we have a double quantity, which has been defined over here. And then you get the item's total emissions. This is our third entry. We get this from the quantity times this part times product dot get CO2 emissions. Then for our cart class, we have the cart array list that I defined earlier. Then we have a function and a method that just adds the cart item into the whatchamacallit. Then we have another method that calculates the final total emissions for that adds all the get item total emissions together. And then we have the display cart. You can now understand why my case 3 seems a little lacking, because here, it's already defined in the cart class. But I think you can understand where it's going. And besides, too much of the theory is not a great thing, so I will now demonstrate how the code will look in practice. So this is our main. Before we begin, I would like to define my main. This is going to be the baseline for whatever happens inside here. So scanner is introduced, file path is introduced, products and cart are introduced, and thus our system is initialized. Well, I start it up. We have a set of choices. 1, we can check the list of products. 2, we can buy some products. 3, we can check our carts. Or 4, we can break out. This is all encased in a while true loop. This while true loop will only stop if the user inputs 4. So let me do a quick demonstration. And this also segue into my case 1, which is just basically reading the file path and then making it into an array list of named products and just reading it out in particular, just reading it out. Note that I split it into 2 parts. This converts the txt file into an array list, and this just reads the array list. If I put them together, it'll probably break it a little bit. But yes, as you can see, all 40 entries, excluding the first row, of course, have been displayed. Very nice, very nice. But this is only one module. The meat and bones, they come in case 2, which is the one I found the most difficulty with, of course. So let me input number 2 here. Now the system will direct you to enter product IDs to buy them, and then type done to finish. Now you may be thinking, hey, why is the product ID not in int status? See here. It's actually in string. But don't worry if you feel a bit anxious about that, because let me do some demonstrations. I'll just enter whatever, and the system will detect it's an invalid input. So error shooting is there, which is very good. But anyways, let's see what I want. For example, let's suppose I want some berries and grapes. Berries and grapes would have product number 27. Let's set that. This is just a demonstration of what my binary search function will do. This method. Sorry if I call them functions methods or methods functions. I get a bit, I'm a bit too, I like Python a bit too much, but I'll try to keep it in topic. Anyways, this is just a placeholder that demonstrates the binary search algorithm I have in place. This will help for searching products, like product classes, like IDs or whatever. Since everything in the carbon footprint txt is already ordered sequentially, binary search works perfectly fine. And thus, I find it very helpful for this case. Just halve it, halve it, halve it, halve it, halve it, until we find berries and grapes. And if you look back into our carbon footprint txt, indeed, berries and grapes are entry number 27. Very nice. Now I can insert my quantity. If my quantity is a negative number, the system will let you know. And then you just reset, and then it'll throw you back in. Let's try this again. Let's say I want now 2 kilograms of berries and grapes. And now 2 kilograms of berries and grapes have been entered into my cart. I'll now showcase that. So as you may see, this is the products class. We have ID, name, and CO2 emissions. Each object is mapped to a certain different column. I already explained this. Cart item, which is our associative entity, contains all of products as well as the quantity that's defined over here. Let's exit our method real quick. And I'll show you my case number 3, which also segue into my cart class. So as you may see here, I have 2 kilograms of berries and grapes, and this has a total emissions of 2.20 kilograms of carbon dioxide emitted. This is done by this whatever you call it, quantity, where you multiply the quantity by the product that gets CO2 emissions, as you see here. And since this cart item has been added into our cart with this statement. And the display cart is a very simple for loop that contains all of these attributes, these new values, the name, the weight, the quantity, and then the carbon emissions then the carbon dioxide that's been emitted. And if I may add, this table constantly updates. Let's go back to method number 2, module number 2, actually. Now, let's say I want product ID number 39. We have farmed fish. Again, 2 kilograms of farmed fish and have been added into cart. We can validate this with with method number 3, as you may see here. Now the cart has been updated accordingly. to feature both berries and grapes and farm fish. Then, once the user feels like they've been satisfied with whatever purchases that they made, they enter number 4, which closes the loop and exits it. Thanks for shopping at Freshmart. Then the total amount of carbon dioxide emissions will be displayed here. This variable just basically takes from cart.get final total emissions. If the final emissions is within a certain threshold, as we see here, it's 50. See here. Good job for eating green. The system congratulates the user. But if it were over it, I'll do a quick demonstration of how that may look. So we go back to our method number 2. Product ID, we'll go for an animal product this time. Product ID number 31. And I want 2 kilograms now. Then we'll exit it, check the cart to validate its existence. And as you may see, it's about 119.2 kilograms of carbon dioxide. Then we exit it. Oh no. Oops. Sorry about that. 119.2 kilograms. As you may see here. Ultimately, I find that this application has lots of potential. For one, it could actually be implemented as an actual way of buying products online with prices that dynamic prices and points, loyalty points that are rewarded. It could be implemented very realistically, and because of the binary search, I can add how many entries I want, so long as they're sequential, of course, and follow the formatting. I could add however entries I want. Like hypothetically, I could have 200 or even 2,000 products in here if I wanted. Of course, there are a couple limitations. More specifically, with duplicate entries. Let me demonstrate. Let's say I want product item number 15. We find soybean oil. If you look here, that's soybean oil, that's correct. I want 1 kilogram of soybean oil. And let's do it again. Then I can exit, check my cart. And as you can see, there are 2 entries that feature soybean oil. However, this is more so of a structural issue than anything, because hash lists, I don't think hash lists are allowed for our models here. So the only thing I can do is just use array lists. But aside from that, there's not much. You could do error testing, input not received. I'll just put in a whatever here. Invalid input, and then I can exit my function. And yes, it still calculates properly. 12 kilograms of carbon dioxide emitted, as you can verify from here. But yeah, thus concludes my demonstration video on how this application might work and the potential uses this may have in a hypothetical online shopping system.